Okay, so this is still assignment 1, constructive line drawing, but this is part 2, cylindrical shapes. So we've already talked about planar shapes. Now we're going to do cylindrical shapes. Now I showed you essentially my lecture on how to measure cylindrical shapes. Now I'm going to do a couple demonstrations where I scale up what we're seeing in our line of sight from our perspective onto a larger page. So the 18 by 24 inch page that we've been working with. Again, the goal is to get it as large as you can on the page without going off. So again, the first thing that you need to know is height, width. This is always the first dimension that you need to be considering whenever you're approaching subject matter. Either the height and width of, say, a whole composition. If I was going to draw this whole area here, it would be wider than it is tall. But in the case of this, it's taller than it is wide. How much taller is it than it is wide? And what do we do about these angles here that we're seeing at the side of the cup? So first thing you want to know is the height. There's two things that you want to know when thinking about that height. First thing is that you want to know that that center line that's describing the height is kind of like an axis line, and it's called the center line. Another term that you could use would be the line of symmetry. Now, not all cylindrical objects are symmetrical. For instance, a cup with a handle on it would not be symmetrical, but the bulk of that cup would be symmetrical. So again, if we're looking at, say, a coffee cup like this, that's a cylindrical object, this main bulk, which is the general shape, the largest part of the shape, is very obviously a symmetrical form. The handle makes it asymmetrical, unless we're looking at it from this way, right? So your perspective on that object might determine whether it's symmetrical or asymmetrical. But regardless, even if I was drawing that asymmetrical cup, I would still be thinking about a line of symmetry for the largest part of the shape. The handle is a piece of the whole. It's a smaller shape that relates proportionately to the larger shape. You're always working large to small, general to particular, simple to complex, okay? So again, we're looking at this center line, and it tells us two things. It tells us about the height that we're going to be making it on the page, and it tells us about the placement that we're going to make it on the page. Actually, it also tells us one additional thing, and that is that on the left side of that line of symmetry, we have a reflection of the right side. So in other words, that line of symmetry is like a mirror image on either side. In the case of this cup, which has kind of a diminishing size from top to bottom, those angles are going in the opposite direction, but they're the same attitude of angle, and they're a mirror image of one another. So when you're deciding, okay, I want to make this object as big as I can on the page, I want to place it in the center of the page, and I want to make sure that I'm not, making it so big that it's going to go off the page. So I would draw that line of symmetry down the middle and leave a little bit of room between the top and the bottom of your page. Now, this is very important. This and this are the total heights. Don't be lulled into thinking that that total height does not include the front and the back of the ellipse. I'm going to go ahead and open this up in Procreate so that I can draw on top of it real quick. Okay. I import that photo. Okay. So when we're talking about the center line, we're talking about something that starts here and moves to the bottom. And it encapsulates the total height. So we know that this and this are on the same plane of space, but it appears optically that this is higher than this. So we have to remember when we make this decision, that moves us from the very top, the actual visual top of the object, all the way down to the actual visible bottom of the object. So when you're making this decision, you're recognizing that this is this back line here. You're not drawing this here and then drawing that ellipse on top of it. All right, so how do we determine the height versus the width? Well, in this case, we have this diminishing size. So we want to think about looking at the height, which is the longer dimension, and comparing it with the width at the widest point. And if you look, that width is about half of the height. So if I find the halfway point here, then I know that this dimension needs to be on either side of that height. So I'm going to make a guess about right here. And here's the beauty of it. All you have to do is move that line over and make sure that it's equidistant from the center of that object. Okay, so that's a very important thing to recognize. And this dimension should equal this dimension, and it does. The next thing that we're going to do is we're going to find the angle of that diminution. So here's my angle. I look at it, compare it, look at it, put my pencil, make a mark. Okay, so there's that one side. Now the cool thing about this is that I can do this. Or I can do this. And I know that if I go in the same direction as that mark that I've just made, then I'm going to have a symmetrical relationship on either side. Now, what's the next thing that we do when we're dealing with that ellipse? Well, we want to know the height of that ellipse relative to the width of that ellipse. Okay? So the height of that ellipse relative to the width of that ellipse. And it looks to me like the height is about 1/4 of the width. Okay, so the height is about 1/4 of the width. Let's test that theory out. So there's our height. Does that look to be about 1/4? Well, it indeed does. So if we take this widest point and we divide it in half, so here's our middle. We divide that in half, and that will be our height. So that is the height of our ellipse, okay? Now this is very important. You find the center of the ellipse, because that center line, that horizontal center line, which is perpendicular to our vertical center line, needs to be in the exact center of the height of the ellipse. So we draw a center line there. Now, using our pencil and our arm, we make that ovoid shape that fits within those boundaries. Okay, so now we have the proper height and width of our ellipse. And you can tweak that by making sure that this is a reflection of this and that this is a reflection of this. And to me, it looks like this needs to come in a little bit in order to be absolutely symmetrical. Now, remember, this ellipse down here is going to be approximately the same form of curve as the bottom of the ellipse at the top. So if we take that halfway point and we translate it down, we know that we can place a center line there, and that that bottom curve needs to fit so that its termination is at the end of that center line and its apex is at the bottom of our height mark. Now there's one more feature here, and again, you've got the whole height versus the width. You've got this part, which is the ellipse, the opening, and then you've got this part, which is kind of like a rimmed lip at the top of the styrofoam cup. We have a couple ways that we can figure out how high it is. Now, one thing I would do is just kind of compare it to the opening of the ellipse. It's a little bit longer, right? So if I move this down and I make a mark and I make it a little bit longer, that's going to give me a good guesstimate as to the width, the height of that lip or that rim, okay? So we could draw that rim here. But how do we know where it begins and ends? Well, again, we just move that ellipse down, draw a line across, and make sure that we have a reflection of this here as well as here. So those curves are all the same. Then all I have to do is move it out a little bit so that it extends outside of that simplified cylinder that we have. And then we can come in, just as we did with the planar shapes, and again, starting at the corners, we can give it a little bit more emphasis. And we've got a recreation or a representation of the styrofoam cup at a larger scale. All right, now let's try one that is wider than it is tall. So the first thing that you're probably going to want to do, if you want to make it as big as you can on the page without going off, remember that's our modus operandi, centering it, making it as large on the page as we can without going off the page, so that it's a closed composition with the drawing as large in scale as we possibly make it. You're probably going to want to turn your page on the horizontal. So your format will not be vertical, now it will be horizontal. Okay? So again, the most important thing here is we're looking for the longest angle. So I know that I want it to be centered in the page, so I'm going to make a mark here and make a mark here so that the distance on either side is equal. Okay. And then I'm going to find the center of those two marks for my center line. Now I'm purposely making it very large. The reason I'm making it large is just to show you that right now all I'm concerned about is that I've established this is going to be my width and this is going to be the line of or the axis of symmetry that's running down the center of that object. So here And here, there's that center line that we have in the object. So the thing that we want to determine now is what is the width of the object compared to the height of the object, okay? So the way that we're going to figure that out is we're going to hold our pencil at the widest point, and then we're going to turn our pencil on the side, and we'll see that it's about half as tall as it is wide, which means that it's this tall, one or the other. This needs to be moved over a little bit. Okay, so that means that it's got to be this tall, right? So I'm going to guesstimate. I'm going to measure that, and I'm going to compare it. Looks a little bit too big, so I'm going to bring it down a little bit. And notice that I'm making certain that this distance and this distance are the same, so that this center height is balanced with this center width, okay? So we know that the sides are going to be vertical because they're vertical sides. And again, I want to stress it's very important to place that vertical, which is half of the width, so that its center is lined up along the center axis that you've determined when you centered those marks in the page, okay? This axis isn't really important, but it is important in so much as that we're comparing this width with this height, and we're trying to center it in the page. We're trying to have the same distance here as we are down here. Okay, so now that we've got that, now we want to determine what? Well, we've got a kind of whole boundary of what it is. Now we want to find the parts. So the next thing is the ellipse. So how big is that ellipse relative to my height? It looks to me to be about a third. So let's make a little mark. 1, 2, 3. A little bit more. 1, 2, 3. So about here is where the bottom of the ellipse is, right? What do we do next? We find the center. That's the center line of our ellipse horizontally. Now we have the center line of our ellipse vertically, and we have the center line of our ellipse horizontally. And now we start to flesh out the ellipse. And I'm literally like moving my whole body. And I'm increasing the pressure as I get a better idea of that shape. Now I move this line down to here, and I place that half of the ellipse above the bottom of my height. I draw a line across, and then again it's just a matter of recreating that elliptical form and then coming in. Now I notice something interesting about this tuna can, and that is that it's got kind of a chamfered edge. So I can come in now with an even more particular part, what I call a tertiary detail, and I can kind of refine that edge that way. The other thing that I've noticed is that, like the styrofoam cup we drew previously, there's a lip. Now what I like to do is make marks, kind of like connecting the dots, that are about the same distance from that top line that you've got. Distance, 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 all the same. That way, as you're drawing it in, you have some lines to kind of shoot for. So just like a little kid would connect the dots, you're connecting the dots. And then we give ourselves some more emphasized lines to finish the drawing off. I especially like to go a little bit darker where one thing is overlapping another thing. Now, another aspect that you might notice in this is that there's a seam back here as well, and it's approximately the same thickness as this. So draw a mark from your top of the ellipse there. And then we can overlap that mark with that mark, overlap that mark, that mark, and we've got our tuna can. Same height and width, same proportional relationships, but larger in scale.